Okay, we'll go ahead and get started. So there's a few things we got to do today. So first of all, my understanding is that Professor Amir gave you a new homework, right? Or has he not done that yet? Oh, he has. Okay. Do you guys want to do that first before we do the sections? Because I was looking at the due date for week 11. It looks like this isn't due until the 5 p.m. of the 22nd. Yeah. Um, so we have to do the sections for week 11 today, and then also do the homework. Which one do you want to do first? No, it's up to you guys. Which one we want to do first? The homework is due on the 30th. Okay. So how do you guys feel? Do you want to do sections or do you want to do homework first? How do you guys feel? Not sure. Oh, so maybe you guys haven't looked at it yet, and you don't know what questions you have to ask yet, huh? Okay. Homework, you'd say. Um. Okay. We could look at the homework first, and then do sections later. I think we would have time to do like one question, and then we can look at the sections for week 11 because Logan Ashbaugh did say that this homework is due on the 30th, and that's a good ways away. Okay, so if anyone could post the link to the homework in the chat, or maybe email it to me, we can get started on that. Perfect. Thank you, Logan James Ashbaugh. Okay. So this homework is about pointers and streams. Okay. So we learned pointers before, right? But we're about to learn streams this week. Because as you can see, week 11 is about streams, right? Let's let's briefly skim through these problems and try to figure out which one we want, which one problem we want to do. So problem one says, write a function that returns a pointer to the maximum value of an array of floating point data. So I take it A is the array, and size is the size of the array. If size is 0, return a null pointer. Well, that doesn't seem too hard. Let's try to find a harder question for us to do. Problem 2 says, write a function that returns a pointer to the first occurrence of a car in a string. Or null pointer if there's no match. So this is going to be of type double, and it says find first. The string is going to be an array of type car, which we're going to call S. And then car C is the car that we're looking for. Also, this question is kind of like the first. It's not too hard. But I can see what some people would need help on it. Question 3 says, define an employee structure. Oh, so you guys learned structs already, huh? That's good. So define an employee structure with a name and employee pointer to the employee's manager. For the CEO, the pointer will be null pointer. Okay. Write a program that defines several employees and their managers. For each employee, print the chain of superiors. Okay. Hint, create a helper function to assign every employee with their name and their supervisor. So this is kind of like a linked list, huh? Because the way a linked list works is that it has two parts. One is the data. The second part is the pointer variable that points to the next data. But in this case, you're not pointing at the data that you're pointing to is actually the employee's manager, right? So you're gonna need a knowledge of linked lists to help you with this, right? And then, oh, so there's 5 problems here, okay? So problem 4 says write a program that reads each line in a file, reverses its characters, and writes the resulting line to another file. Suppose that the user specifies input.txt and output.txt when prompted for the file names. So if input.txt has this, the program should write this to output.txt. Now, I don't think you can do that yet. Even though this is kind of simple, I don't think you guys can do that yet because you haven't learned streams yet, right? Okay. So maybe we'll save this.
We're just learning streams right now.
Huh?
We're just learning streams right now.
Oh, okay, good. All right. And then problem 5 says, write a function that returns a vector of strings called decompose, and it accepts one argument called string address. Using string streams that decomposes an address into city, state, and zip. Okay. So, in other words, you have a string called address, and as always, address contains a city, state, and zip. What this is trying to do is what we're trying to do is break this string into its constituent parts, where this is the city, this is the state, and this is the zip, right? So the way now I can see how people getting tripped on this one. So what you would need to do is take the string called address and write a C++ program that finds the point where the comma is located, and then everything before the comma you take as your city. And then the very next string that follows is going to be the state. And then the number that follows is going to be the zip. Now, I can picture us writing a C++ program that does this, but one thing that you might get tripped up on is what if the state has 2 words instead of 1? Like, for instance, North Dakota, South Dakota, New Hampshire. Those states have a space in between. So how would you parse that? Because you can't, because after you get the name of the city, you can't just say, okay, get the rest of the string up to the space, and that'll be the name of the state. Because what if you have North Dakota or South Dakota? Then it would take North as the state, and then everything else is a zip, and that wouldn't really work.
Well, between the city and the state, there's a comma, so we could probably use that. And then the zip code's always a number, and state's not a number.
Okay, so maybe after that's a good point. So maybe after you remove the city from the string, maybe you could look at the end of the string, retrieve the last 5 characters of the remaining string, and say this is the zip, and then the rest of it you say this is this. Okay, yeah, I like that idea. Okay, so these are the 5 homework problems. Which one do you guys want to do? Um, How do you guys feel?
Maybe we should start with the most difficult one.
The most difficult one? If you ask me, I think the most difficult one would be 3. Just in case you haven't learned linked list yet. You guys want to do problem 3?
Sure.
Yeah. Okay. So so this was the class example that I made before. I'm just gonna put this to the. Oops. I'm just gonna put this to the side here. We don't need this right now. And then I'll just open a new Visual Studio. This is problem 3. Okay. I'll just call this. What number homework is this? Yeah, it's 4. Homework 4, problem 3. Now I should warn you guys. I don't use linked lists very often, so I might be making mistakes here and there. That's all right. This is something we'll get through together. Okay, so let's remind ourselves what the problem is. Define an employee structure with a name. Name will be of type string, obviously, and then employee pointer pointing to the employee's manager. Write a program that defines several employees and their managers. For each employee, print a chain of superiors. Create a helper function to assign every employee with their name and their supervisor. You can use dynamic memory allocation helper function. So, okay. So it seems to me like we're going to copy the linked list class from one of our previous Xi books and just change a little bit of things. Like for example, what data before could have been, the data in this case needs to be of type string since we're using a name, and then the pointer also needs to be a type string since it's going to point to the name of the employee's manager. So let's go back to one of the previous labs and let's see if we can get the linked list class. So now, did you use? Yes, you did. Okay. I know you guys haven't really touched on classes yet. So this might be a look. So some of the things that I might do might seem a little bit confusing to you. That's okay. Just try to follow along the best you can. So here's what I'm gonna do. We need to define an employee structure. So I think we're gonna call this employee. So I'm going to, here's what I'm gonna do. I'm gonna copy this since it's almost exactly similar to the thing that we're trying to make. So I'm gonna copy that. And then I'm gonna, let's add a new item. I'm going to choose .h file and I'm going to call this employee. Over here, I'll paste everything, making some changes here and there, right? So first of all, the name of the class needs to be employee. Okay. Now, for underneath private, we should put our data types that it's going to use. Now, the homework states it quite simply. It said it needs two parts. One is a string called name, and then an employee pointer to the employee's manager. So I'm going to get rid of this. There's no int involved here. We need a string called name, and then we need an employee pointer. Pointing to the next, pointing to the employee's manager, right? Let me go back here to the employee's manager. Okay, so I guess I'll name this variable manager. Like that. So what were some things that needed to be rewritten? This is, I know you guys haven't learned classes yet, but this is a default constructor, and this is a parameter constructor. Oh, there's 3 parameter constructors. Insert at front. I don't think we need this. We needed the right.
The assignment told us to create the employee as a structure, not a class. I mean, they're kind of similar, but like, you think it'd be okay creating it as a class instead of a structure? Yeah, I don't know if he's wanted like a structure specifically or just like something like that.
I'm not sure if he would mind if he used a class instead of a struct. And also, I'm not sure if classes and structures are almost exactly the same. One of the big differences is that classes can inherit while structs cannot. That's all. So I don't think he would.
Oh wait, I think this prompt is kind of wants us to use inheritance too.
Oh yeah,
Since,
have you learned inheritance already? Because I don't think you would learn inheritance until much later. Because let's see, yeah, inheritance is all the way down here in week 14.
Well, because I mean the manager is an employee and the CEO is a manager. That was what my thinking was.
Yeah, managers are all employees, right? So it's okay to just have a employee be a manager or someone else, because the way this is gonna work is that it's going to it's exactly similar to a linked list, except instead of saying like the structure is exactly the same as a linked list, except instead of saying like what was it? Instead of saying like in this particular example, instead of saying inventory, we say employee, and instead of string item, we say string name, and then we have this another data type that's of the same type, but as a pointer pointing to their manager. So one thing, so I think it's worthwhile to draw a visual of this. So one thing, the way I'd like you to visualize it is that imagine you got I don't want that. So you got things pointing to things like this. So maybe you got maybe this guy's name is Bob. This guy's name is Jack. This guy's name is Sue, and they're pointing to each other, right? Like so if it's pointing like this, we're saying that Jack is the manager of Bob. And then if it points like this, we're saying Sue is the manager of Jack. And then everything ends when we go to the CEO. Like I'm gonna say the CEO maybe their name is Max. And and there could be a long list of employees, right? But eventually they would point to CEO, and then obviously the CEO points to null pointer, right? Because there's no one above the CEO. So maybe I'll say you point to. So you can see that this is exactly like a linked list, and because the Zybooks always always did linked lists in the form of classes instead of structs, we should do it the way that they did because that's the way we've been doing it for a while. It would be easier for us. And that's actually the reason why I copy pasted that and just changing things around. So do we understand what this assignment's trying to do?
Yeah, that's fair. Which Zybooks assignment was it again?
You know, a whole bunch of these had pointers or a linked list. So this one had a linked list, and this is the only one that I unhid. And then on week 9, this one had a linked list too. So you can copy the structure from either lab 9.8 or 10.6. Anyways, let's go back here. So so one thing that's one thing that you haven't learned about classes yet, and one thing that I've been meaning to teach you about classes is that classes always require a constructor, which allows us to create default parameters for whenever we create a new class of this type, right? So I'm going to do this. I'm going to go over here and I'm going to say include, and I'm going to include my employee.h file, okay? And because this is a file that I created, I have to put it in double quotes instead of chevrons, like that. All right, so now I have access to the employee class that I made. Right? So here's what I'm going to do. I'm going to make a default constructor for employee. Okay. So here's what I'm going to do. Inventory node. I'll replace this with employee. And employee has two things. One is the name, and one is the manager. So I'm going to say this dot name equals empty string is fine. There is no member called number of items, so let's delete that. And then next, I'm going to say Slayman Toki asked in the chat, so this is all on one project. What do you mean by that, Mr. Slayman Toki? I don't understand your question.
Oh, we haven't really covered how to make a header file in code blocks.
Oh.
Yeah, so basically what you do is when you construct the main file, like as usual, you go to file and then new and then go down to file and then header file is the first option right there.
Oh, okay.
That helps. and
Okay.
we're working in the header file. Yeah.
All right. Hopefully, if there's time after this, we can look it up together. How to put a header file on code blocks, because if you're doing this on Visual Studio, it's very simple. You just hover over Add New Item, and you say whatever.h. I don't know how you do it in code blocks, but that's okay. We can figure that out. So instead of saying next node ref, we should say manager instead. And manager points to null. So, so in case you get, I know you guys don't know what a constructor is. This is what a constructor does. I'll demonstrate it here. So because this constructor exists right now, I should comment all this out since it's gonna make some errors in case I. So because this constructor exists right now, if I said employee one. So at this point in time, I created an employee called employee one, and which contains two, and employees always contain two variables, one called name and one called manager. Because I didn't define what they are, what happened as a result is that this line 8, calls the default constructor, which says, oh, you're making an employee that has no parameters. This constructor here is the default constructor. It's going to assign default parameters. So I'm going to say your name is going to be blank or empty string, and I'm going to say your pointer is going to be pointing to null. Right? That's what the purpose of a constructor is. If I didn't have a constructor, and if this was commented out, and then I said this line, what this is essentially doing is that this is the same as uninitialized data. Name is equal to gobbledygook that was in the register in the memory address before I was using it, and manager is also pointing to something. And handling uninitialized data is very dangerous. It's the same as saying string name, and I don't initialize it to anything, and I say cout name. This would give you an error because name is not defined. Same thing as here, but that's what a constructor is. Okay, so now that we got that, so I'll comment that out. The next thing we got to do is make if we have a default parameter constructor, the next thing we got to do is make a parameter constructor. So once again, I'm going to call this employee. Now you take, employees require two things. One is going to be a name, right? Because employee doesn't have something to type in. I'm actually going to delete this. I'm going to delete this. I'm going to change this to name. And instead of next node ref, I should change this to manager. So by doing this, I actually now have two constructors. One is a default constructor that accepts no parameters. The other one is a parameter constructor that accepts one parameter called, I should change this too. Instead of saying item, and I should say name. I should change the name in it too. So by doing this, the purpose of this constructor is, let's say I make a new employee variable called employee 2. But inside of parentheses, I'm going to say, hey, this employee 2, their name is going to be Frank. Like that. So when main.cpp calls line 9. The compiler is gonna say, oh, you have an employee called employee2, but you're passing a string variable called Frank to it. I'm gonna go to the employee class and see if there's a constructor that accepts a string, and there is. So the way that this constructor works is that Frank will be passed as name init, and they'll set name equal to name init. So as a result, employee2, their name is going to be Frank, and they're going to be pointing to null. Employee1, their name is going to be empty string, and they're also going to be pointing to null. Does that make sense?
Okay, wait. A quick question. So null means the same thing as null pointer, right?
I believe
In
so.
this case,
Yeah.
okay. Okay.
Yeah, I never really understood the difference between null and null pointer. I believe they're interchangeable. Null is 0 in integer content. Null is, oh, so, okay, so there is a difference between null and null pointer. So null is if you want to give a lack of value to like any other data type, like a string or an int or something. But null pointer is something that you should set a pointer equal to.
So since this is a pointer, should we be using null pointer?
Yeah, that's weird. Like, because it's a pointer, shouldn't this be null pointer instead? So how come Zybook says null, but Google says we should use null pointer? That's weird.
I thought Zybook said null pointer.
Actually, if you go, because I pulled this from this lab, it looked like it had them set to null. That's weird because next node ref is a pointer variable because we know it's a pointer variable because it has the dereferencing operator here. So why is this null instead of null pointer? That's a good.
I feel like the difference might be inconsequential at this level.
Maybe. Yeah. You might be right. Let's just not care about it too much. Okay. So we got two constructors here. We don't need this. We also don't need this. Actually, do we need this? Insert a node at the front. Nah, we don't really need this. We only made this function for the sake of the lab that we pulled this from. So I guess we don't need this. But what about this? Do you guys think we need to keep the function that retrieves the next node? Do you think we need it?
Maybe.
Maybe. Okay. I guess we'll keep it. So I'll change you to employee. We can keep you as get next, but instead of saying next node ref is not the pointer. Manager is the pointer. So I'll put this over here. And then the function that prints it, we'll definitely need that. So how about instead of saying print no data, we rename this to print employee data. So we're gonna see out this, and instead of saying number of items, let's return the name. And then actually I think this will look a little nicer. Let's say employee name is equal to, and then we'll see out this dot name, and then we'll say this employees manager. And instead of saying this, we'll say, actually, no, we don't need this. The reason it had this is because the thing that I pulled it from had two data types. One is a string, one is an int, but it never returns the next item. So this is actually fine. Okay. Perfect. So here is our employee header file. This is the header file that we quote unquote created, right? So what we gotta do now.
Wait, so what does the print function look like?
Oh, I can show you right now. So here's what we're gonna do. So if I said employee 2 dot print employee data, and I gotta put open close parentheses because this is a function. When this line is called, because employee's name is Frank, it'll say employee name colon Frank. You guys want to see that? Yep, employee name Frank. So yeah. So if we need to add more functionality to this class, we can add it later. Right now, this fulfills our intents and purposes, right? All right, let's remind ourselves what the homework's asking for. Oops, did not want to do that. All right, write a program that defines several employees and their managers. For each employee, print the chain of superiors.
Should we make a CEO tag to know when to stop?
We could, but there's a couple ways we can do that actually.
Then we'd probably also have to make a function to include all of the superiors of a given employee.
Like the chain of superiority.
Yeah. Yeah, I think we have to print out the whole hierarchy.
Yeah. How many employees should we make? Well, so the hint says create a helper function to assign every employee with their name and their superior. How would this helper function work though? What would the function be like? Create new employee and say employee is
Maybe something that takes 2 employees as parameters and just assigns one as the supervisor of the other.
yeah, that could be what the instructions is asking us to do. Okay. Create a helper function to assign every employee with their name and their superior. So I did pull this code from this lab. Let's see if the main function had a function that populated the linked list. Okay, so the way this worked was that it had input before, and the way that it did it is that it used the new keyword, and so it creates a new node. If we were to implement something like this, we would change this to employee and change this to name and then delete this. But the way that it would insert that node to the list is that.
So this algorithm only works if they're in order then, right? Like if we input them sequentially.
Right.
Yeah. Do we want to do that?
We could. So the way that this lab retrieved the data is that it was input. How about Okay, guys, I have an idea. So I know that you guys just started learning to use streams, right? Here's a thought. What if we created a text file that contains the names of employees and the very first name is a CEO? Would you guys want to? I think that's a good idea. What do you guys think? I know you guys haven't learned streams yet, but I think now would be a good opportunity to learn it. What do you guys think?
It's definitely an option.
Okay. Now, one thing that we're definitely missing is some kind of method to insert new nodes to the linked list, because at this point in time, whenever we create a new node, it's always pointing to null. But we should have them like in a chain. Well,
should we make another constructor then?
No. The like no, like all these functions before, whenever they wanted to have the pointer equal to something, it doesn't use a constructor. It uses a different type of. It uses a different function altogether. Like this program used insert at front instead. Then this is the function that we created, but we don't want to insert at front because we already said before that we want the first name to be the CEO, and if we inserted nodes this way, what we would be doing is making the last name the CEO instead. So let's look at a different example and see how they used it. So this is the one I was looking at before. Let's look at the 9. So you guys remember this lab? This lab required us to make a print song info function and then have the main.cpp call it. Let's see how this program attaches the nodes. Okay. So they had a dummy head node, right? And then they said head node equals new song node. Okay, guys, now that I've seen this, I think I have a better idea. How about instead of having a text file that contains the names of the employees with the first name being the CEO, let's have the main function define a dummy head node, and the head node is going to be the CEO, and then the text file is going to contain all the employees that are the subordinates to the CEO that go in order, right? I think that's a good idea.
So is the text file going to contain the name of the CEO then?
No, the text file will not contain the name of the CEO if we're going to do it like this.
So we initialize the CEO,
yeah,
like with the name.
Yeah. So we can say, wait, but however, it says, do not print it. Sorry. So what if I said, like, say if I got rid of all this, actually let's put this here and put this here. So we could get rid of this and say employee head node and say head node equals new employee. And inside of here, we'll put the name of our CEO. So maybe the CEO, I'm going to put CEO in parentheses in front of their name, just to indicate that the CEO. And maybe I'll name them blank. How's that? No operator matches these operands. Employee equals employee. Okay. All right, that might not work. So I've ran into a little snag here. It looks like it doesn't like it if I set if I use the assignment operator between nodes, because employee is a class that I created. So I wonder if this song node class had an overload function. Let's see. Yeah, I run into problems when I do this, and the reason why is because I don't have an overload function for the assignment operator to apply to employee type. But how come this file did not have an overload function for the assignment operator, but it's still able to do this? Yeah, we're kind of getting close to time here. I'll tell you what, guys. Actually, let's get rid of this for now. We can talk about this more in the next meeting, but and I guarantee that by the next meeting, I'm going to have more. I'm going to look into this further, and I'm going to have hopefully I'll have a finished solution for you guys. But yeah, it's kind of strange that the assignment operator works for song node, but it doesn't work for employee. And the way to get around that is with an overload function. But this one did not have an overload function. That's odd. Maybe it's a different compiler. Okay, well, unfortunately, we spent all our time looking at this problem. But so in the next Over the weekend, I would like you guys to do the week 11 sections on your own. If you like streams and exceptions, it's actually streams and exceptions. It's actually very easy. So all that this does is that the purpose of streams is to retrieve data from an input file or some other source, and then have your C++ program process that. So instead of getting your user inputs from C-ins and C-outs, you'll be retrieving data from input file. And another thing you can do, instead of outputting the process data to the console like the way we've been doing, you could instead have the data be outputted to another text file. And the way you do that is using stream variables. And this discusses all about stream variables. But these sections, you already know them. They're quite easy. So here's what I'm gonna do. I would like you guys to do these sections over the weekend, and when we meet again, I will definitely have a finished solution for number 3. And then if you guys want, we can also look at the other problems as well. Man, it's been a really long time since it's been a really long time since I used linked lists. This is a learning experience for me too. So, is that a good plan, you guys? Just do the 11 sections on your own, and then next week I'll have more on this question for you. Sounds good? Okay, awesome. All right, have a good weekend, and I'll see you next Tuesday.
Hey, thank you.
You're welcome.